We can also solve systems of nonlinear equations without using technology. We can employ substitution or elimination just like we did whenever we did systems of linear equations. So let's take a look at example 5 where we're going to solve by substitution. I notice that my second equation, which happens to be the linear one, is already solved for y. So that makes it really easy to do my substitution. I am simply going to plug in that y is equal to x plus 5 from the second equation into the first equation where I see y. So let's do that. All right, so my equation will start out 2x squared minus 3x minus, and now I need to say what my new version of y is. I know that y is x plus 5. And in fact, let me go ahead and write that in purple so that it'll be kind of tied to what I circled there, x plus 5. And then that is all equal to negative 5. All right, now we just need to simplify. We've substituted, which was our step number 1 right here, and now we're going to simplify. So let's go ahead and say 2x squared minus 3x. I want to distribute the negative, so I'll say minus x and minus 5. Don't forget that it applies to both pieces here, and then that's equal to negative 5. Going to continue simplifying by combining some like terms. I notice that I have a negative 3x and a negative x, and I can combine those as my next step. 2x squared minus 4x minus 5 is equal to negative 5. Now I want to move the negative 5 that's on the right over to the left because in order to keep working with this, I need a 0 on one side. So I'm going to add 5 to both sides, which cancels here. It also actually happens to cancel on this side as well. This is going to make our job a little easier. So all we have left is 2x squared minus 4x, and that's equal to 0. I notice that I have a greatest common factor here, and remember that when we're dealing with quadratics, the first thing you want to do is look for a greatest common factor. I see a GCF of 2 and an x, so I want to factor that out in order to make my job a little easier. So let's divide by 2x on the left-hand side. I'm just factoring it out. You don't want to divide it out on the whole thing. You will lose an x and in the process lose one of your solutions. So you cannot just divide everything by 2x on both sides. We are just factoring right now. So I'm factoring out a 2x and saying what I have left. And what I have left is x minus 2, and that's still equal to 0. So now I'll apply my zero product property. Remember that says that in order for two things that are multiplied together to equal 0, one of those two things has to be 0. So that means that either 2x is equal to 0, that would be one possibility for x, or x minus 2 is equal to 0. Let's take a look at the left equation first. In order to solve this, I need to divide both sides by 2, and that's going to leave me with x is equal to 0. On the second equation, I need to add 2 to both sides in order to solve, and that's going to leave me with x is equal to 2. So I know that x can either be 0 or 2, but now I need to also know what y is. So I will go back up to the original equations, and I'm going to plug in x into either of these equations and then solve for y. Since the second equation is simpler, it only has a linear equation instead of a quadratic, and it's already solved for y, it makes sense to plug into that one. So we're going to plug into y equals x plus 5 with what we know x to be. So y is equal to x plus 5, but we know that x is 0 for this case. So we can say that y is equal to 0 plus 5, or y is equal to 5. For our second case, again with y is equal to x plus 5, but now I know that x is 2, so I'll say 2 plus 5, giving me a y value of 7. So my two solutions are either an x of 0 and 5, or I can also have this solution, or I do also have this solution of 2, 7 for x and y. So this one has two solutions where the quadratic and the line cross.